Rigging is the planned movement of material and equipment from one place to another using ropes, chains, hoists, or other types of equipment. To safely accomplish any rigging operation, you have to be able to select the proper equipment to use for the job, determine if the equipment is in acceptable condition, and properly carry out the procedures involved in rigging and moving the load. Rigging jobs can vary from routine lifting maneuvers to complex and specialized operations. But regardless of the job, some of the basic components are likely to be the same. In general, synthetic fiber ropes are stronger and more resistant to stretching than natural fiber ropes. Also, some synthetic fiber ropes are more resistant to chemicals and abrasion than natural fiber ropes. However, synthetic fiber ropes are susceptible to damage caused by long exposure to sunlight. For that reason, they should be stored in a cool, dark place. Like wire rope, chain can be used in many different rigging operations. But chain weighs much more than wire rope of the same capacity, and it has less ability to stretch, which sometimes causes it to snap without warning. However, these disadvantages are balanced by chain's ability to turn tight corners without suffering undue wear or damage. One type of chain that's used in rigging is common chain. It's constructed of interlocked welded links of forged steel. In general, the capacity of the chain is determined by the thickness of the metal from which the links are made. Most rigging operations require some basic hardware to link separate pieces of equipment. For example, wire rope has limited flexibility, and it should never be tied in a knot. So various types of end fittings and connectors are needed to attach it to other sections of rope or chain or to a load. With a wedge socket, the end of the wire rope is passed through the socket, looped, and then reinserted into the socket. A wedge is positioned inside the loop to prevent the wire rope from pulling out of the socket. The dead end of the rope is secured by clamping a separate piece of wire rope to it. Like an open socket, a wedge socket has a removable pin that can be used to attach the socket to other equipment. During a rigging operation, the load that's being moved must be connected to the device that's doing the lifting. Often, the connecting link between the lifting device and the load itself is a length of wire rope, chain, or synthetic material called a sling. Like any equipment, the equipment used in rigging is subject to wear and damage. This wear and damage can seriously affect the capacity of the equipment and lead to accidents that could cause injuries and destruction of property. To prevent these problems, rigging equipment should be inspected before it's used to ensure that it's in good condition. Equipment inspections are a vital part of rigging safety. All rigging equipment should be inspected before each use, and if the equipment is used for an extended period of time, it should be inspected on a regular basis. Government agencies, as well as private industries, have rules regarding equipment inspections and allowable limits of wear and damage. Let's look at what's involved in some of these inspections now. The thing to remember about a wire rope inspection is that any significant wear or damage can affect the strength of the rope and make it unsafe. Also, since wire rope is susceptible to damage such as broken wires, you should always wear gloves when you're working with it to prevent cuts and scratches on your hands. Most of the damage to a connector or fitting can be detected through a visual inspection, but some defects, such as hairline cracks caused by overloading, aren't easy to see. To check for these types of problems, other methods, such as liquid penetrant testing, are sometimes used. These types of tests use liquids that are able to seep into tiny defects in the surface of a component to make them visible. In addition to inspecting the equipment that's used in a rigging operation, it's also important to check the load that's being moved. For example, a load or piece of equipment should be checked to make sure that there are no loose parts that could fall off when the load is lifted, and no damaged or defective lifting lugs or pad eyes. If the load has eye bolts for rigging, they must be screwed in all the way. Also, keep in mind that the way the load is rigged depends on the type of eye bolts that are used. Shoulder-type eye bolts, which have a widened area just below the eye, are suitable for angular lifts. Straight or shoulderless eye bolts should be used for straight lifts only. One piece of equipment that's sometimes used in rigging is a derrick. A derrick is basically a stationary crane that's used primarily for straight lifting, although some derricks can provide some lateral movement of the load. Cranes are used to lift and move materials and equipment from one place to another. There are a number of different types of cranes available. Some of them are mobile. Others remain stationary for the most part. In this part of the program, we'll look at a few of the more common types of cranes used in rigging. Cranes are typically operated in noisy areas, and the crane operator often can't see either the load or the area where the load is supposed to be placed. Sometimes rigging personnel use radios to direct the crane operator, but often a rigger or flagman on the ground uses hand signals. In this part of the program, we'll look at some of the hand signals commonly used for different types of cranes. As we do, keep in mind that even though the signals we'll see are standard, flagmen and crane operators must always agree on them before a lift is attempted. Here's a list of the hand signals that we'll examine. Use the Go button to view the signals in sequence. After each signal plays, you can select Replay if you want to view the signal again. This is the Raise Load signal. It tells the operator to raise the load using only the lifting tackle. The boom should not move. The Raise Load Slowly signal tells the operator to raise the load slowly using only the lifting tackle. This signal is produced by making the Raise Load signal while holding your other hand flat above the signal. The Lower Load signal tells the operator to lower the load using only the lifting tackle. The boom should not move. The Lower Load Slowly signal is produced by making the lower load signal while holding your other hand flat beneath the signal. It tells the operator to lower the load slowly using only the lifting tackle. This is the Raise Boom signal. It tells the operator to raise the crane's boom. The Raise Boom Slowly signal tells the operator to raise the boom slowly. It's produced by making the Raise Boom signal while holding your other hand flat above the signal. Here's the Lower Boom signal. It tells the operator to lower the crane's boom. The Lower Boom Slowly signal tells the operator to lower the boom slowly. This signal is produced by making the Lower Boom signal while holding your other hand flat beneath the signal. The Raise Boom Lower Load signal tells the operator to raise the boom and lower the load at the same time. It's produced by extending your arm, pointing your thumb upward, and opening and closing your fingers repeatedly. The Lower Boom Raise Load signal tells the operator to lower the boom and raise the load at the same time. It's produced by extending your arm, pointing your thumb downward, and opening and closing your fingers repeatedly. The Extend Boom signal is used for cranes with telescoping booms. It tells the operator to extend or push out the boom. The Extend Boom signal can also be given with one hand. To do this, hold one hand against your chest, keeping your fist closed and your thumb pointing upward toward your chest. Another signal that's used for cranes with telescoping booms is the Retract Boom signal. It tells the operator to retract or pull in the boom. The Retract Boom signal can also be given with one hand. To do this, hold one hand against your chest, keeping your fist closed and your thumb pointing away from your chest. The Swing Load signal tells the operator to swing the boom and the load to the left or right. It's produced by extending your arm with your hand open so that your fingers point in the direction that you want the load to swing. The Travel Crane signal tells the operator to move the crane to another position. This signal is typically made by rolling one hand over the other in the direction that you want the crane to move. The travel bridge signal tells the operator to move the bridge of a gantry crane in one direction or the other. It's produced by raising an open hand to about shoulder height and making a pushing motion in the direction that you want the bridge to move. The travel trolley signal tells the operator to move the trolley of a tower crane in one direction or the other. This signal is produced by holding one closed hand at about shoulder height with your thumb pointing in the direction that you want the trolley to move.